Welcome back to another lesson for our Natural Sciences Grade 7, brought to you live by SmartCaps, proudly sponsored by the Department of Basic Education, VT Africa Holdings and Companies. Today, we are going to have a short recap of our lesson on separation of mixtures, as well as have an activity or an assessment to assess or see how we are doing and how the lesson is progressing. Please remember to log into Hello Smart. You sign in as a guest. This is going to be our permanent class ID. You connect using this class ID to all our assessments and we can interact. Yesterday we looked at methods of separating mixtures. We know that mixtures can be separated physically because there's no chemical reaction between our components or substances in our mixture. We looked at hand sorting, where you are hand picking or selecting materials that are in your mixture in trying to separate them. We continue to look at sieving, where we use a metal sheet that has holes, and those holes allow for materials of a particular size to pass through them. This is mostly used in separating solids. And we separate solids, and the property that we exploit in separating solids from our mixture is, of course, size. So we look at size, we use size of the solids in our mixture in order to separate them when we are sieving. We got to look at filtration, where filtration is a method that uses separation of solids from liquids. So we use a filter paper, a funnel, in order to separate our solids from our liquids. The liquids will drip through. Our liquids will drip through, and our solids will be contained or held in our funnel. We also got to look at another separation procedure where you're looking at separating solids by exploiting their property of magnetism. How are they magnetic? Do they react to a magnet? And we said when you are having a mixture of sand and metal, it's a mixture of sand and metal, and you're looking to separate the metal from the sand. How do you go about it? You place a metal over it, and because metals are magnetic, this is a property belonging to metals. Because metals are magnetic, they will be attracted or pulled towards our magnet, and they can thus be separated from the mixture, leaving behind your sand and having separated your metals. We also got to look at evaporation. What am I saying? Evaporation. We also got to look at evaporation, where evaporation, we are going to boil or heat up our liquids or the mixture such that the liquids can vaporize, and once the liquids have vaporized, they will be removed from our mixture and our mixture can remain. So here's our mixture having particles inside, having maybe another liquid inside. So we will heat this up. We'll put some heat And as the temperature of this increases and hits the boiling point, one of the liquids will hit its unique boiling point, and once it hits its unique boiling point, it will start to boil out. It will come out as vapor, and that vapor, as shown in this beautiful image we have in the on the board, it will vaporize, and is vaporizing. As it is vaporizing, will remain with whatever is remaining in our mixture, which is those solids remaining and the other liquid that has not yet reached its boiling point. That other liquid that is yet to reach its boiling point, meaning you've at least been able to extract or remove or separate one of the liquids which has boiled out or vaporized and separated or removed from our mixture, right? And looking at this image, here's our liquid vaporizing, and the lady or gentleman here is collecting that vapor by cooling it using, he is cooling it using the ice, and upon cooling it, what happens to the vapor? It condenses. The vapor condenses. You remember phase change? Condense. The vapor will condense and collect in our beaker, right? So there's evaporation and there's cooling or condensation such that we can collect our liquid. So this is one liquid that was able to boil. After boiling, it was cooled or condensed such that it can be collected and hence removed from our mixture. It has now been removed from our mixture. And the same procedure applies or takes place when we're looking at distillation. In distillation, we use the same process as vaporization, where we apply heat to our mixture. Here's our mixture. That's our mixture. We apply heat to it, and once it hits a particular temperature, the substances inside will heat up. And once we reach a temperature at which one of the substances is its boiling point, the substance will vaporize, right? Upon vaporizing, we collect it through this tube, and we use this to condense it. We will condense it by applying some cool water around the tube such that it condenses and collects. So we'll be separating that particular liquid from the mixture using heating, and once it vaporizes, we will condense it and collect it in a separate tube or in a separate container. And that's all well and great. Let's look at one final method of separation of mixtures. Let's look at when we are trying to separate colors. If you have a mixture of colors, what happens when we're trying to separate them? You can separate them, and we're going to explore, we're going to look at how we can separate them. Looking at this poster alongside, it's a very beautiful poster, and that has just losing color because of sunlight and rain, right? Rain pours on top of this over time. Heat warms this up as well. And what happens? The colors run along the poster. The colors run along the poster. And why do they do this? It's because of this particular separation method called chromatography. Chromatography, yes. It's a technique in which you can separate colors or fluids because you can run through a liquid in a mixture. So here's our Here's our colors. I'm just gonna draw a sample. Let's have this as paper, having a particular color or varying colors as green, as blue, as red, and all these varying colors. If they have those colors and you run through a liquid, that liquid, which is called a mobile phase, will allow us to have these colors run along the paper, and they will run at different rates. Why do they run at different rates? They run at different rates because they react differently to this mobile phase or to this liquid that we are using. How do they react differently? They will dissolve into that liquid different. They will carry through that liquid differently. How do they carry? So there will be, others will be carrying through the liquid because of having large particles. Color or inks will have different particle sizes. And because of them having different particle sizes, those with small particle size will be able to carry in the liquid or the mobile phase, right? That fluid that we use to run through, and they will carry down our paper, right? And those that have large particles will settle or take longer to run through. They'll settle or take longer to run through. And in failing to run through, meaning they will settle higher up the paper, they will settle higher up the paper, whilst particles with smaller, whilst ink with smaller particles will be able to run easier. Will be able to run easier and come settle lower down the paper, meaning they will run through the paper at different rates due to the particle size of these inks or colors, right? Some will settle higher up the paper, while some settle lower down the paper due to their particle size. And that's all well and great. So I would like us to look at or look into an activity real quick. For you to partake in this activity, of course, you log into HelloSmart, www.hellosmart.com. And once logged in, you follow the prompts, you sign in as a guest, you log in using this particular class ID. You log in using this class ID, 598751. Add your name and we interact. So here's the activity. So in this activity, this is what we're going to do. Let me add a page. Let's have a mixture. Here's our mixture. Here's our mixture, and in our mixture, this is what we have in our mixture. I'm going to make a list showing what we have in our mixture, and we're going to have this activity. Here's our mixture, and we're going to look at how we can separate this mixture and answer the questions. In our mixture, let's say we have 1, water, 2, ethanol, 3, ions, ion. Let's have ions. Let's have sand. Let's have water, ethanol, ion, sand. Yeah, that's enough. Let's have this mixture having these 4 components. So it's a mixture having these 4 properties. It's water. It's ethanol. We have iron. And we have sand. Right? So we have these four in our mixture. They are all here. There's our iron settled at the bottom. There's our sand mixed in. There's our water. And mixed in with our water is our ethanol. Right? Our water and ethanol mixes like that. So there's our mixture. We are looking to separate all these four and have them as individual substances, right? So we have this mixture and let's have the activity. So we have the beaker having sand, iron, ethanol, and water. And when we were looking at our separation mixture, separation methods or procedures, we looked at using or exploiting properties of substances in order to separate them. And that's great. So in this activity, we're gonna need to remember that, right? Let me help you connect or have you connect and interact with me. Start. And up here, we have our the number we're going to use to log in and interact with me. We have the 598751. That's the number you're going to always use in interacting with me through these activities. So how do we go about separating them? Let's answer the following questions. The undissolved solids can be separated from the liquids using what? We have four options to choose from. We need to separate the liquids from the solids from the liquids. We need to separate the solids from the liquids. How can we go about this? Of course, in a number of ways. Let's choose from the ones below. When we were doing our activity, I remember us discussing how we have a process that can easily separate liquids from solids, which was, yes, we have a few to choose from, but the easiest was, of course, filtration. Remember, where the solids can collect in our funnel and our filter paper, whilst the liquids can drip through. And we are going to choose filtration, of course, right? What's the second question? The undissolved solids. The undissolved solids can be separated by what method of separation? The undissolved solids. So we have the undissolved solids. You remember they collected. So here's our mixture. We take this mixture, we separate the solids from the liquids using filtration, right? We have we're going to be pouring this. We take this mixture, we pour it into a funnel and place a beaker for our liquids to sift through. And here's our mixture. We are going to pour it there. We are going to line our filter with, or our funnel with filter paper. That's a funnel and that's filter paper. And as we pour this here and it settles there, our solids will collect in our funnel. You remember that. Our solids will collect in our funnel. Our solids will collect here. That's, in our case, the iron and the sand will collect there, whilst our water and ethanol will able to sift through and collect at the bottom, where we'd be having our ethanol and water, right? We would have, in this case, been able to separate our liquids from our solids using filtration. Awesome. So we are able to separate our liquids from our solids. So now the question is saying, now that you have these solids, which is now sand and iron, how do you separate those two? We have a mixture now of just solids, which is sand and liquids. What can you do to separate those, to separate these? We said here we have filtration. We are going to use filtration in order to separate the undissolved solids from our liquids, right? And how can we separate the undissolved solids? So in our undissolved solids, we have sand and iron. How can we separate the two? It's solids. We are going to exploit the property within them in order to separate them. Because we have ions and we know ions are magnetic, we're going to use magnetic separation. You remember that? Yes, we're going to use magnetism to separate them. So here we are having this mixture, now that has collected. And how can we separate these two? Of course, we place a magnet over these. We place a magnet over these, and these will easily and simply enough separate, right? I'm gonna just try throw a magnet there. That looks like a magnet enough. And we're going to separate the ions from the sand using a magnet because we know that iron is magnetic and we use that procedure, right? So in this case, the ions will be attracted towards our magnet whilst the sand remains at the bottom. And in that way, we have separated separated our solids, our ions from sand, because we know that ions are, yes, you guessed it, of course. So now we have sand and iron separate. What else are we remaining with? We're remaining with those liquids, which are now methanol and we have now methanol and ethanol and water. How can we separate ethanol from water? it's a mixture that is in liquid state. We are looking to separate those two liquids from each other. How can we go about it? We have filtration there. We have magnetism there to separate the ions from the sand. And now we need to separate the liquids. What do we do? The question is saying the liquids can be separated by what? Because of their difference in boiling points. You remember when we were discussing difference in boiling points, we had that beautiful kettle where we heated up our mixture, because at some temperature, one of the liquids will boil out first, leaving behind the other liquid, right? We used evaporation, right? We used evaporation, and that was all great and well. So we're going to use evaporation, meaning we are going to take this mixture, that is ethanol and water. That is now ethanol and water. And we're going to separate this mixture using what? We're going to heat up this mixture. Upon heating up this mixture, we know that ethanol having a lower boiling point compared to water will evaporate out first, leaving behind our water, right? Awesome. So that's one way we can separate our ethanol from our water, because ethanol has a boiling point of 78 degrees Celsius, whilst the water has 78 degrees Celsius, whilst water has a boiling point that we know to be 100 degrees Celsius. And that's how we're going to separate these. We're going to heat them up or vaporize them such that one will vapor out of the mixture, leaving one behind. Awesome. So let's go back to our mixture and think. Let's see. If I am to take our mixture and add something else to it, let's add salt to our mixture. Let's add salt to our mixture. So if we're having salt to our mixture, and we use filtration to remove the ion and the sand, which are our undissolved solids. So remove the ion and the sand, what remains? We're remaining with a liquid solution or liquid mixture having water, having ethanol, and having dissolved salt, because we know that salt put in water will dissolve, right? Dissolved salt. We will have dissolved salt in our mixture. We know how we can separate our water from ethanol, but how can we now dissolve or separate our dissolved salt from liquid? Dissolved salt. How do you separate it from liquid mixture? How do you separate it from liquid mixture? So you remember we said we can separate it from our liquid mixture. We can separate solids from liquids using filtration. But filtration can only help us in separating undissolved solids. Because why? Because our solids will collect or remain in our funnel as our water drips through. But what happens with dissolved salt? If it is dissolved, the water will trickle through together with the dissolved salt, because the salt is right in the water. How can you separate them? Filtration will not work. But we know that we can use what? We know that we can use what? We know that we can use distillation. And how does that help us? We can use distillation, and how does that help us? Distillation will allow us to have Here's our liquid. We heat it up. We know that in distillation, we heat it up, temperature increases. Due to boiling point, the ethanol, once the temperature hits 78 degrees, the ethanol will boil out, right? And we use that tube to collect it. We can have a tube, have it condensed there, and we collect it. We have ethanol. And that's when our temperature is 78 degrees. Our ethanol is out, meaning we are remaining with our beaker having now water and our dissolved salt. So how do we separate the two? You continue heating it up. We continue heating it up, and once it hits 100 degrees Celsius, we know that our water will start to vaporize. And upon vaporizing, it will leave the solution in the form of a gas, and we collect it with a tube. We condense it and collect it using a funnel, right? We use a funnel and we collect it. Here's our water vaporizing out because it has hit 100 degrees. We cool it down such that it can condense, meaning we lower the temperature here. Lower temp. We lower the temperature here and we collect it. Meaning what would be remaining? What would be remaining is our undissolved salt. Now salt will remain there because there's no more liquid at all. There's no more ethanol. It has been distilled. There's no more water. It has been distilled, leaving behind our salt. And that's how you can separate them. Now we know the different procedures and ways we can separate mixtures from liquids. And I will be able to see you in our next lesson. I hope we fully understand that and we appreciate the activity. You interact with me at HelloSmart. You sign in as a guest. You use the login number as provided, and we interact. Thank you very much. Our time is up. I'll be seeing you in our next lesson. Thank you.